Thank you, assembled guests, black hole enthusiasts. Black holes are the most mysterious objects in the universe. They're cloaked by an event horizon where their gravity prevents even light from escaping. And yet, the matter that falls onto the event horizon is superheated, so that before it passes through, it shines very, very brightly. We now believe that supermassive black holes, millions, even billions of times the mass of our sun, exist in the centers of most galaxies. And because they are so small, though, we've never seen one. There, though, they can outshine the combined starlight of all the constituent stars in those galaxies. The best idea we have of what they can look like come from simulations like this. The infalling gas that's superheated lights up a ring of light where photons orbit the black hole. And interior to that is a dark patch where the event horizon itself prevents light from escaping. The Event Horizon Telescope project is dedicated to the idea that we can make an image of this black hole, that we can set a ruler across this shadow feature, measure the photon ring, and test Einstein's theory where they might break down. It also will allow us access to a region of the universe where we can study precisely the energetics and how black holes dominate the cores of galaxies. To do this, we worked for over a decade to link telescopes around the globe to make an Earth-sized virtual dish. The aim is to, the Event Horizon Telescope achieves the highest angular resolution possible from the surface of the Earth. It's the equivalent of being able to read the date on a quarter in Los Angeles when we're standing here in Washington, D.C. In April of 2017, all the dishes in the Event Horizon Telescope swiveled, turned, and stared at a galaxy 55 million light years away. It's called Messier 87 or M87. And there's a supermassive black hole at its core. And we are delighted to be able to report to you today that we have seen what we thought was unseeable. We have seen and taken a picture of a black hole. Here it is. This is a remarkable achievement. What you're seeing here is the last photon orbit. What you are seeing is evidence of an event horizon. By laying a ruler across this black hole, we now have visual evidence for a black hole. We now know that a black hole that weighs 6.5 billion times what our sun does exists in the center of M87. And this is the strongest evidence that we have to date for the existence of black holes. And it is also consistent, the shape of this shadow, to the precision of our measurements